Picture an 86-year-old man. He is a Nobel laureate, a mind that literally unlocked the fundamental building blocks of the universe. But right now, in this freezing moment, he is completely destitute. He is homeless, hiding in the icy woods of Germany, sleeping in haystacks. His spine is physically fusing together, and he is screaming out loud in unimaginable agony as the artillery fire of World War II rages relentlessly all around him. He has just lost his home to an Allied bombing raid. His life's work, his massive library, his irreplaceable scientific diaries, every physical trace of his towering intellect has been reduced to ash. Caught in the dirt between advancing American forces and the retreating German army, he is waiting to hear if Adolf Hitler is going to execute his last surviving son. You might know him as the father of quantum physics, but the story of Max Planck is a staggering, unfathomable tragedy. It is a moral tightrope, the agonizing paradox of an extraordinarily rigid, deeply conservative thinker who accidentally broke the universe while he was just trying to enforce its absolute rules. Welcome to the dark corners of genius. If you are captivated by the hidden, tragic truths behind the architects of our reality, take a moment to like this video, subscribe to Legendary Lives Unveiled, and share this journey into the abyss of history. We are dedicated to resurrecting the shadows that textbooks leave behind. To understand how a mind that demanded perfect harmony navigated a violently out-of-tune reality, we must return to the beginning. Born in 1858 in Kiel, Germany, Max Carl Ernst Ludwig Planck was practically engineered by his ancestry to revere tradition. His family was the epitome of the German academic elite. His father was a distinguished professor of constitutional law, and both his grandfather and great-grandfather were prominent theology professors at the University of Göttingen. Law and theology, the ultimate heavy bastions of absolute rules. He was raised strictly within the German tradition of Bildung, a cultural concept focused on holistic self-cultivation, rigorous classical education, and, most importantly, unshakable ethical discipline. His bloodline was completely defined by the pursuit of absolute truths. Whether it was the unbending law of the state or the infallible law of God. The idea that the universe possessed a strict authority structure was the absolute foundation of his worldview. It instilled in him an unwavering Prussian sense of duty to both the state and the church, fostering a profound, deferential respect for institutional authority. He was no rebel. He truly believed that institutions and laws were the only bulwarks humanity had against chaos. Yet, science was not even his first calling. He was a massive musical prodigy. Possessing absolute pitch, he sang in boys' choirs, played the cello and piano brilliantly, and even composed a full mini-opera titled Die Liebe im Walde during his university years. He seriously considered making music his life's work, seeking the harmony, structural order, and mathematical proportion that classical music shares with physics. But in 1874, when he had to choose a path, he went to the University of Munich and sought the advice of the prominent physics professor, Philipp von Jolly. Jolly delivered what has to be one of the most infamously terrible pieces of academic advice on record. He told the brilliant young Planck to stay away from physics, calling it a dead end and a finished science. The prevailing attitude of the late 19th century, famously echoed by Lord Kelvin, was that the universe was essentially solved. Newtonian mechanics explained motion, Maxwell's equations handled electromagnetism, and the grand architecture was complete. Jolly essentially told him the building was finished, leaving only a few insignificant gaps to fill and a few decimal places to calculate. Faced with a completely drawn map, an ambitious genius would typically seek unknown lands to conquer. Not Planck. In a move perfectly revealing of his unique psychology, he explicitly told Joly he had absolutely no interest in discovering new things. He didn't care about novelty, not even a little bit. He merely desired to understand and deepen the foundations of the absolute, unshakable laws that already existed. He didn't want to expand the house. He just wanted to inspect the bedrock. He sought certainty, not fame. This obsession with certainty had been sparked earlier by his high school teacher, Hermann Müller. Müller had introduced the teenage Planck to the law of the conservation of energy, using a vivid, slightly morbid example. Imagine a worker lifting a heavy stone onto a roof, thereby storing potential energy. Then, imagine that stone being loosened and dropping directly onto the head of a passerby. As it falls, the potential energy is perfectly, mathematically converted into kinetic energy. For Planck, this grim German high school example was not a neat trick. It was a profound philosophical revelation. It proved there were laws with absolute universal validity, existing completely independent of human agency, emotion, or subjective experience. Underneath all the messiness of human existence, there was an incorruptible order. The universe had rules, they were perfect, and they absolutely could not be broken. Driven by this almost religious awakening, he dove into thermodynamics, the study of heat and energy. In 1879, at age 21, he submitted his summa cum laude doctoral thesis on the second law of thermodynamics, heavily focusing on the concept of entropy. Entropy dictated the arrow of time. In any closed system, disorder always increases. Heat flows from hot to cold, never the reverse. You cannot unmelt an ice cube. It was an irreversible, absolute, deterministic law of nature. Despite his brilliance, the scientific establishment completely ignored him. His absolute idols, titans of German physics like Gustav Kirchhoff and Hermann von Helmholtz, simply shrugged at his work. Kirchhoff openly disagreed with his math, and Helmholtz literally didn't even bother to read the thesis. It came down to a fundamental philosophical clash. Planck viewed thermodynamics from a macro perspective, seeing entropy as a continuous, top-down absolute law. The physics community, however, was leaning toward the micro perspective of atomic theory, believing individual invisible atoms bouncing around created the effects of heat and pressure. Planck hated that idea. He was deeply suspicious of atomic theory, viewing atoms as perhaps a useful hypothesis, but absolutely despising the reduction of his beautiful, continuous laws into chaotic bouncing particles. He spent years as an unpaid lecturer, a private docent, living with his parents and methodically grinding away in complete isolation. But that exact stubborn academic isolation uniquely positioned him to tackle the greatest mathematical crisis of the era. Enter the problem of black-body radiation, the ultraviolet catastrophe. At the Imperial Institute of Physics and Technology in Berlin, experimentalists were studying idealized physical objects that absorb all electromagnetic radiation and, when heated, emit radiation. Like a blacksmith's forge, hotter iron emits higher frequency, shorter wavelength light, moving from dull red to blinding bluish-white. The Berlin physicists took incredibly precise measurements of these spectrums and asked theoreticians for a mathematical formula to predict the exact curve of light. The theoreticians relied on classical physics, specifically what became the Rayleigh-Jeans law. But the math produced an absolute nightmare because it treated the electromagnetic energy inside the oven as continuous waves, like strings vibrating on a guitar. The math forced energy to be shared equally among all infinite high-frequency modes. The horrifying result? Classical physics mathematically predicted that opening a hot oven door wouldn't just release heat. It would immediately vaporize you with an infinite blast of ultraviolet radiation, X-rays, and gamma rays. As frequency increased toward the ultraviolet, the predicted energy shot straight up to infinity, an impossible universe. Meanwhile, Wien's displacement law worked brilliantly for high frequencies, but completely failed at lower ones. Holding two broken halves of a map, Planck looked at the highly precise data in October 1900. He engaged in a happily guessed interpolation. Squishing Wien's law and the Rayleigh genes framework together, he found a single mathematical equation that flawlessly matched the experimental curve across every single frequency. But a mere guess felt intellectually dirty to a man obsessed with foundational certainty. The next 2 months became the most intense, desperate work of his life, as he tried to derive it from first principles. To prove the underlying physical reality, he committed what he famously called an act of despair. He abandoned his lifelong prejudice and adopted the statistical mechanics of his intellectual rival, Austrian physicist Ludwig Boltzmann. Boltzmann argued entropy increased simply because of statistical probability, vastly more ways for atoms to be disordered than ordered. Relying on probability felt to Planck like abandoning absolute truth, like admitting the universe was just rolling dice. But the desperation won out. To make the math work, he couldn't treat the energy as a continuous flowing wave. He had to pretend the energy was being chunked out in tiny, indivisible, discrete packets. He called them quanta. He wrote the equation that changed the world. E equals h nu. Energy equaled the frequency multiplied by a tiny, seemingly arbitrary number known as Planck's constant. Energy wasn't a continuous ramp. It was a staircase where you could stand on step 1 or step 2, but never at step 1.5. This minimum transaction amount solved the catastrophe. Low-frequency red light had short stairs easily climbed by thermal energy, but high-frequency ultraviolet waves required a colossal step the oven simply couldn't provide. The infinite curve collapsed. On December 14, 1900, he presented this to the German Physical Society, birthing quantum theory. Yet, the ultimate irony was that Planck did not even believe in the physical reality of his own discovery. He viewed the chunky staircase of energy as a pure mathematical artifact, a bookkeeping trick. He assumed it would smooth back out into a classical ramp and spent the next decade trying to sabotage his own legacy by welding the quantum back into classical framework. It took a 26-year-old patent clerk entirely outside the academic establishment, Albert Einstein, to prove the physical reality of photons in his 1905 paper on the photoelectric effect. Planck, the rigid Prussian conservative, had accidentally authored the most radical, reality-breaking revolution in science, eventually winning the Nobel Prize in Physics in 1918. By the 1920s, he was the undisputed patriarch of German science. But just as he reached the zenith of his professional life, his personal universe began a catastrophic descent. An unrelenting symphony of chaos was preparing to shatter his reality. Up until this point, we must acknowledge that Planck possessed an incredibly vibrant, deeply anchored home life. He was not merely a stuffy academic. In 1887, he married his childhood friend Marie Merck. They had 4 children, a son named Karl, twin daughters Greta and Emma, and a younger son, Erwin. Their home in the Grunewald suburb of Berlin was legendary, the cultural and scientific heartbeat of the city. Brilliant colleagues and former students, like the physicist Lise Meitner, frequently visited. Meitner wrote beautifully of the atmosphere there, noting that beneath his stiff Prussian public persona, Planck exhibited unrestrained childish glee, playing marathon games of tag in the garden with his kids. He was an avid alpinist who loved grueling mountain hikes. He was profoundly grounded by his family, but in 1909, the anchor breaks. His wife Marie dies, likely from tuberculosis after 22 years of marriage. Planck is utterly devastated. He writes to a cousin that her grave is where, quote, "My lost happiness is sleeping." He is left with 4 children, though he remarries a couple of years later to Marga von Hueslen and has a son, Hermann. The sheer wave of tragedy surrounding his first family was only just beginning to crest. The outbreak of World War I in 1914 sets the cascade in motion. Planck, swept up in nationalistic fervor and Prussian loyalty, initially supported the war effort. But the industrialized slaughter shattered that illusion. In 1916, his eldest son, Karl, was killed in action at the Battle of Verdun. Losing a child to war is a trauma shared by millions. But what happens next to his twin daughters, Greta and Emma, introduces a sheer statistical horror that defies belief. In 1917, Greta, who had recently married a professor named Ferdinand, dies in childbirth. The baby survives, leaving the family shattered. In response, Emma, Greta's identical twin sister, moves into Ferdinand's home to help care for her orphaned niece. Bound by shared grief, Emma and Ferdinand fall in love and marry. Then, in 1919, exactly 2 years after her twin sister died, Emma also dies in childbirth. The exact same circumstances, the exact same outcome. Out of the 4 children from his first marriage, only one, Erwin, is left alive. How does a human being process that level of compounded suffering? How do you wake up, put on a suit, and deliver a lecture on thermodynamics when the universe has systematically dismantled your reality? Biographers point to his deep internalization of Prussian Stoicism. You do not collapse, you endure. But more profoundly, it was his philosophy. He possessed a deep, albeit non-dogmatic, religious faith. He viewed the universe as unfolding according to a higher absolute will. His deterministic belief that nothing is truly random gave him a framework for his grief. He bore it with a quiet, terrifying fortitude. And then, there was the music. During this dark period, Albert Einstein had moved to Berlin, largely recruited by Planck. Despite being scientific opposites, they became incredibly close friends. Einstein would visit with his violin, Planck would sit at the piano, and Erwin would play the cello. They formed a trio. Amidst the wreckage of their lives, they mourned within their music. Music, with its strict mathematical rules and harmonic order, provided a sanctuary where the laws of the universe still made sense. Through this shared trauma, Planck and his son Erwin forged a profoundly unbreakable bond. But just as Planck settled into this quiet rhythm, acting as the elder statesman of global science during the Weimar Republic, the political landscape collapsed. In 1933, Adolf Hitler became chancellor, at 74 years old, as the president of the prestigious Kaiser Wilhelm Society. Max Planck was plunged into the most agonizing moral dilemma of his existence. Deeply rooted in his lifelong deference to state authority, his initial instinct was to stay and weather the storm. He believed the extreme rhetoric of the Nazi regime was merely an anomaly, that the responsibilities of governing would moderate. But within months, the civil service law was passed, mandating the expulsion of Jewish professionals. Brilliant scientists were being humiliated and forced to flee. Realizing passive buffering was failing, Planck used his immense prestige to secure a face-to-face meeting with Adolf Hitler in May of 1933. His specific goal was to beg Hitler to stop the dismissals, focusing on his friend, the Jewish chemist Fritz Haber, a German patriot who had literally saved the German World War I effort by figuring out how to fix nitrogen from the air for explosives and fertilizer. Planck fundamentally misjudged the entity he was speaking to. He brought rational, pragmatic arguments to a man possessed by fanatical ideology. According to Planck's own post-war recollections, Hitler responded with a terrifying, escalating tirade. Hitler claimed he had nothing against Jews per se, but that they were all communists. Working himself into a manic frenzy, Hitler started slapping his own knee, shouting faster and faster that he had nerves of steel. He screamed that if dismissing Jewish scientists meant the annihilation of contemporary German science, then Germany would just do without science for a few years. Overwhelmed by the physical intimidation and pure irrationality, Planck was forced to fall silent and back out of the room. He returned crushed, realizing the state authority he revered had been hijacked by an evil immune to logic. What followed is the most heavily scrutinized chapter of his life. Did he become a dissident or complicit? Concluding that open revolt was suicidal for German science, he urged compliance. When his colleague Otto Hahn suggested organizing a mass protest of professors, Planck talked him out of it, arguing that for every 30 men who protested, 150 opportunists would arrive the next day to denounce them and take their jobs. The most intensely criticized moment came regarding Einstein. When Einstein publicly renounced the Nazi regime from abroad, the government demanded the Prussian Academy of Sciences condemn him. Terrified of the academy being destroyed, Planck signed a declaration effectively criticizing Einstein. Contemporaries like Lotte Warburg wrote in her diary, asking why Planck didn't just resign in protest. Why hunch his shoulders instead of throwing his head back and damning them all? The historian John Heilbronn described Planck as a deeply moral man trapped in immoral circumstances. His conditioning to revere the state became a psychological trap, yet in the shadows, he acted. He exploited legal loopholes to secretly enable Jewish scientists to keep positions at the Kaiser Wilhelm Institutes. He quietly helped his arrested nephew emigrate to London. And in 1935, after the stateless, exiled Fritz Haber died in Switzerland, Planck organized an official commemorative meeting at the Kaiser Wilhelm Society. The Nazi Ministry of Education explicitly forbade any state employees from attending. Planck defied them. Standing before a room of independent scientists and the wives of forbidden professors, he led a glowing tribute to a Jewish scientist, right in the heart of Nazi Germany. But appeasing the regime to save science was an illusion. By 1938, the Nazis pushed Aryan physics, dismissing relativity and quantum mechanics as Jewish science. Forced out of his posts, Planck was labeled a white Jew by ideologues. And as World War II plunged the world into an inferno, the tragedy returned. In February 1944, a massive Allied air raid struck Berlin. A bomb annihilated his Grunewald home, his library, his correspondence with Einstein, his personal diaries, his scientific notebooks detailing the birth of quantum mechanics. The entire physical record of his existence burned to ash. But that was nothing compared to the apocalyptic blow that followed. His youngest son, Erwin, had become a civil servant deeply involved in the secret resistance against Hitler. Following the failed July 1944 assassination plot at the Wolf's Lair, the Gestapo arrested thousands. Among them was Erwin Planck. Subjected to brutal interrogation and tried before the notorious People's Court, Erwin was sentenced to death in October 1944. The desperation of the 86-year-old Planck is gut-wrenching. He put heaven and hell in motion, writing to Adolf Hitler and Heinrich Himmler. He literally wrote, "As the gratitude of the German people for my life's work, which has become an everlasting intellectual wealth of Germany, I am pleading for my son's life." He completely humiliated himself. Through SS channels, he received official assurances that Erwin's sentence would be commuted. It was a sadistic deception. On January 23, 1945, Without any warning, Erwin Planck was executed by hanging at Plötzensee prison. Planck was fundamentally broken. "No words can describe what I have lost," he wrote to a niece. The man who believed the universe was a symphony of absolute order had watched every single instrument in his life be systematically smashed. His spine began to fuse, causing excruciating agony. Fleeing with Marga to a friend's estate near Magdeburg, they were caught in the crossfire of the advancing Allied and Soviet forces, leading to that terrifying scene in the freezing woods. Yet, he did not just fade into the background. Found by an American military intelligence unit, directed by scientists who had fled to Göttingen, he survived the war. Recognizing that rebuilding a democratic Germany required reviving its science, British authorities, led by Colonel Bertie Blount, needed an untarnished symbol to replace the tainted Kaiser Wilhelm Society. Despite his compromises, Planck's international reputation for integrity and his ultimate tragic victimization made him the only figure capable of uniting the survivors. Nearing 90 years old, he provided the moral weight required. In February 1948, just months after his death, the institution was re-established as the Max Planck Society, today an absolute juggernaut of global research. In his final years in Göttingen, he lectured on profound philosophical questions, fiercely fighting the Copenhagen interpretation championed by Niels Bohr, Werner Heisenberg, and Max Born. They argued through the uncertainty principle that the subatomic world was probabilistic, that the universe was just rolling dice. Planck, standing shoulder to shoulder with Einstein, despised this. He birthed the quantum, but hated the chaotic teenager it grew into. He was a strict scientific realist, arguing that determinism held true even for human psychology, reconciling free will by stating that a conscious mind analyzing its own choices introduces a new variable. In a famous 1944 speech in Florence, the father of quantum physics made a staggering claim. "There is no such thing as matter in itself. We must assume behind this force the existence of a conscious and intelligent mind. That mind is the matrix of all matter." Deeply aware that the probabilistic universe had won the day, Planck formulated a profoundly cynical observation about human knowledge. He understood the stubbornness of the human ego, writing that a new scientific truth does not triumph by convincing its opponents, but rather because its opponents eventually die. Or, as it is ruthlessly paraphrased today, science advances one funeral at a time. When we look at the totality of Max Planck, the arc is breathtaking. A man who desperately sought the absolute unbreakable rules of nature, and in his obsessive pursuit, accidentally broke the universe into quantum chaos. He endured a level of personal sorrow that defies human comprehension, walking a devastating moral tightrope in a regime of irrational evil, yet maintaining a profound spiritual belief in the harmony of existence. If science truly advances one funeral at a time, what deeply held truths of our modern world are currently blinding us? What terrifying, accurate reality is waiting for us to simply get out of the way? If this exploration has made you see the universe and the incredibly complex, tragic minds who decoded it in a different light, make sure you hit the like button, share this with a fellow curious mind, and subscribe to Legendary Lives Unveiled. Your engagement ensures we can continue to unearth these monumental stories. Keep questioning everything, because sometimes the absolute truth you are looking for is just waiting on the other side of an act of despair.